Polyatomic ions. So if you see a big word, what do? You break it down into smaller pieces. Polyatomic. Poly means many. Polygon, polynomial, many. Polly wants a cracker. There's many polys. See? So poly, many atoms. Atoms. Well, of course there's many atoms. No, these are many atoms together as one ion. What do you mean, Mr. G? Well, let's take the next slide. First, of course, be calm, be prepared, and let's study our polyatomic ions. So, what are they? They are atoms, that I just said. They're polyatomic ions that are charged particles made up of two or more atoms together. So, some of these you've heard of already. Nitrate, not nitride, nitrate. NO3, parentheses, -1. So these NO3s hanging together as a group, one nitrogen, three oxygens hanging together. Together, they have a charge of -1. Notice I have parentheses. I'm going to be using parentheses a lot. I'm going to be using them more than you're supposed to, but you'll see why I do it. And follow along, please. Thank you. So hydroxide, maybe you remember that one. That's OH, -1. Sulfate, like shampoo. Mr. G, what does chemistry have to do with it? I want to be a hairstylist. Oh, do you use sulfate-free shampoo and conditioner? You do? Oh, good. Do you know what that means? Now you do. Welcome to chemistry. Even as a cosmetologist, you need to know this stuff. So sulfate, SO4, parentheses, hanging out together as a -2. Most of them are minuses. This is one of the exceptions. It is ammonium. NH4, parentheses, +1. So that's a +1 ion, a cation. You don't see too many of them, so that's why I'm pointing it out to you. So let's take another closer look at these little guys that we just saw before. Ammonium. Here's a Lewis structure. So if you want to draw Lewis structures, you don't have to. But here they are. And here's a space filling model. So you can see that the nitrogens in the middle and around it are 4 hydrogens. And there they are. And they stick together for now. So ammonium. So it's NH4. And use parentheses to let you know it's a polyatomic ion that stays together. So what happens in the parentheses stays together. And they behave as a single ion. So they stay together. So sulfate, hydroxide, nitrate. See, they're all together, and they all behave as one unit for now. Here's ammonium, the +1 ion. Now, of course, I'll slide up here so you can see. Where am I? There I am. Here it is, NH4. It's a +1. Here's this ball and stick model. Like, ooh, it's a tetrahedral. Yes, it's got 4 things around it. Yes, tetrahedral. Ammonia that we use for cleaning, like in Windex or whatever, is actually ammonia gas dissolved in water, which makes ammonium ions. So it's ammonium hydroxide, which is what makes it a good cleaner, is the hydroxide. But we'll get to that later. So when you smell ammonia, it's like, ammonia. Oh, it's really nose cleansing. It's used as for wake-up salts. So, smells pretty rough. Okay, so with the polyatomic ions, you need to be very, 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 did I say that enough? Very careful with the spelling and the numbers, because sulfate, sulfite, and sulfite sulfide. Sulfate has 4 oxygens and has a charge of -2. Sulfite has 3 oxygens and a charge of -2. Sulfide is no parentheses. Why no parentheses? It's not a polyatomic ion. That's just the plain sulfur off the periodic table, which we did before. There's only one element, S. So you don't need parentheses to hold together a polyatomic. It's not. It's just S. So S is sulfide. So be very careful. Notice with this one, there's no parentheses. We'll talk about that in a second. Nitrate, nitrite, and nitride. Be very careful with those last letters and those last numbers. Notice the nitride is just the element with the charge. It's not a polyatomic ion, so be careful. So how do you do polyatomic ion writing formulas and stuff? Okay, so first, you need to practice getting to know the polyatomic ions. That's the worksheet first. Then, after you're done practicing that, we're going to write the ions. So ammonium is NH4 plus 1. You write the parentheses. And carbonate is CO3 minus 2 parentheses. So look, you've written the ions. Yay, you're 3/4 of the way there. So now what you need to do is do the same thing that you did before, is plus 1 and a -2. Do they cancel? No, they have to crisscross. So how do we do that? It's a little tougher. The 1 goes down, and the 2 over here goes down outside of the parentheses. Remember, what in the parentheses stays, leave them alone. So the 2 comes down here. The 2 comes outside the parentheses, which says there are 2 of these ammonium clumps. 2 of them. And when we do counting atoms, we're going to see that it's 2 times N and 2 times 4 H's. So there's actually 8 H's in that clump, but there's 4 in the ammonium. There's 2 of them. But worry about that later. So, ready? Ammonium, there's 2 of them. And the carbonate, there's only 1. Now, here comes the catch. Don't mess with the numbers inside the parentheses. Officially, if there is no number outside the parentheses, like a 1, the 1 here normally would disappear. And if you're doing it the right way, these parentheses also disappear. So, but these parentheses that have the 2 there are stuck. So the parentheses with the 2 is there. The parentheses, the CO3 without the parentheses is not. I'm going to recommend leave the parentheses. Can't go wrong.